I'm going to make a quick attempt to cover everything that I've learned so far in EKG in one illustration. Starting off, I'm going to begin with the anatomy of the heart. We understand that this is the right atrium. This is the left atrium. Blood comes into the atrium, into these different atrium, and then it's going to get pushed down into the right the ventricles, and then it's going to be pushed out. In this case, the blood that is deoxygenated comes in from the body into the superior vena cava. Into the right atrium. From the right atrium, it is pumped down into the right ventricle, and then from the right ventricle, it is pushed out into the lungs, where it becomes oxygenated again. This doesn't really come off of here. This isn't anatomically correct, but it's just to show what happens. On this case, the blood, as I just said, it went to the lungs. Now, after it gets oxygenated, it goes from the lungs in through into the left atrium. Then it gets pushed from the left atrium down into the left ventricle, and then it gets pushed from the left ventricle through the aorta into the body. And it goes through the body, where it goes through all the stuff back to the capillaries, becomes deoxygenated, and then again comes in through here. And it repeats that cycle like this. And it just repeats that over and over and over again. Now, we're going to go into really quickly the anatomy of what's going on here with the nervous conduction in the heart. So a signal here begins in the sinoatrial node, and it's transmitted from the sinoatrial node to the AV node, okay? And then from the AV node, this is often called the SA node, AV node, the signal goes through the AV bundle, where it then splits into a right bundle branch and a left bundle branch. The left bundle branch is a little bit thicker. So they travel down here through the septum and these different branches. The left bundle branch is going to break into a posterior fascicle and an anterior fascicle, okay? Whereas the right bundle branch will just continue to come down here. Then they break out into Purkinje fibers, which has the whole thing. So the signal goes here, down to here. So SA node, AV bundle, right bundle branch, left bundle branch. On the left side, posterior fascicle, anterior fascicle, and it kind of follows that pattern. There's a little bit of a delay right here, so there's enough time for this to pump and then this to fill up again, and just allows it to happen without problem. So if you got a block right here, then let's say so your SA node is cut off, then what's going to happen is the AV node is going to take over, and the AV node is going to pump a little slower than the SA node pumps. So you're going to see a delayed heartbeat, and also you're going to see that the atria are no longer pumping, or they're no longer contracting. So the ventricles will still contract, but they'll contract slower, because this is a fast pacemaker, this is a slower pacemaker. Now, if the AV node gets knocked out, then you're still going to see the atria contracting totally normally, but since the signal has to travel through here, if this is taken out, then what's going to take over for these ventricles is the Purkinje fibers, and the Purkinje fibers are very, very slow. So you're going to see a really slow, weak contraction of the ventricles, but the atria will be normal. Okay, going on now, how about reading electrocardiograms? So in the case of reading electrocardiograms, we have lots of different ways that we put leads on people's body. The first system to talk about is the limb leads. It's also called the bipolar leads system. So essentially what you do is you're going to put a lead on someone's right arm, a lead on someone's left arm, and then a lead on somebody's left foot. Okay? So in this case, you always think of the image or the detection going from positive to negative. Okay, so the right hand is always negative, always. So the image, I guess, of what you're saying, the reading is always going to go this way, towards the hand. And the first one is going to go from the left hand, which is positive on top, negative on bottom, positive to the right, always negative right hand. That's lead 1. Okay, I drew it up here, lead 1. All right, lead 1. Now lead 2 also goes to the right hand. Both lead 1 and 2 both go to the right hand, and lead 2 starts from the positive foot. The foot is always positive, so the foot it goes from the positive left foot up to, again it goes positive to negative, up to the negative right hand. So that's lead 2. Now the only lead that we have left is then going to be the one that's going to go from the foot to the hand. Since we know that the left foot is always positive and the right hand is always negative, therefore, we can figure out, obviously, then it has to be the opposite on over here. So the left hand is it's going to go from the positive left foot up to the negative bottom part of the left hand. So those are the limb leads. 1, 2, and then 1, and then 2, and then 3. And that's what we get. So then we take those leads, we take these lines, and we put them down to center, so they're centered right over the heart. And so what that's going to look like is you're going to see something like this. I don't know if you can see that very well. I have lead limb 1 going straight across the middle, taking an image of the heart. It would look like this. So here's the heart. Here's the person standing up. Lead 1 is going to go straight across like this. Okay. Lead 2 is going to come straight across like this. And then lead 3 is going to come straight across like this. Okay? If you were to look at degrees, like how many, if this was like, 360 degrees, whatever, what you would see is you would see lead 1 would be at 0. You would see lead 2 here would be at 60 degrees. You would see lead 3 at 120 degrees. So 0, 60, 120. Now we're going to look at the augmented voltage, or sometimes it's called unipolar leads, and this is done a little bit differently. Rather than being on the arms, they just put it right here, here, and then down here at the foot or whatever, or it's just down here somewhere. So you're going to have right, left, and foot. Right, left foot, and the heart is considered the negative. Remember, it always goes from positive to negative. The heart's negative, it means these are all going to be positive. So it's going to go in like this, okay? So they call it augmented because apparently the reading was really small, so they had to increase the voltage on it in order to get a reading, something like that. So basically what's happening with this one is we're going to have augmented voltage right, which is going to take an image here. If you look at degrees, it'd be 210 degrees, okay? So 210 degrees coming straight down like this, and then the next would be augmented voltage left, which would come at, if you look at degrees on this one, this would be negative 30, coming straight down like this. And then if you were to have this one down here, this would be at 90 degrees, which would be AVF, augmented voltage from the foot, and that would go straight up. So when you put all that together, it looks like this, which can seem kind of confusing. But what all these are is almost as if you're taking an image of the electrical conduction in the heart, and it's reading it. And if it's going one direction will be positive and one direction will be negative, depending on how that relates to the vectors. Which brings us to another point. In the heart here, we have all this electrical conduction, and if you're going to try and choose a direction that this electrical conduction has, because usually electrical conduction has to start from one place and has to go to the other place, and so you're trying to figure out what's the direction in here. Okay, overall, you're going to take all the electrical conduction direction in this whole heart and put it in some direction. It's going to go down to the left and a little bit anterior, sort of like this. Okay, so but however, there's lots of small vectors in here of force, and when you look at individual vectors, so let's say I have one vector pushing this way and I have one vector pushing this way, and this one has a vector force of 2 and this one has a vector force of 2, but they're both kind of going out away from each other like this. Well, I could sum these two up by putting a big one in the middle that was a 3, because it's kind of the sum of these two is a 3. That makes any sense. It's almost like think of people pulling on something with tug of war. Even though they're kind of going in different directions like this, together it adds up. Hopefully you understand vectors. Anyways, so when we're when we're looking at this, these readouts that we're going to have on the EKG, you've seen a little line that goes up and down. That's going to be kind of a representation of what it's doing in relation to the vectors of force, or vectors of electrical force in the heart. And it's going to show up on these different readouts. Okay, there's one other way of measuring the heart in the 12-lead system, and this is going to be the precordial leads. And so for the precordial leads, we have a bunch of different angles that we're taking. And instead of coming down like this, all these directions like out here, this is actually coming inward. This is giving us like a three-dimensional view of the heart, what's going on. So this one is coming, from forward to back. And so starting out, the first lead is going to go starting here on that would be the Yeah, on the right side. Okay. So it starts, I believe it starts right here, and you would go down like it's like the fourth intercostal space, third intercostal space. I have to look it up again. But anyway, it's coming in like this. This is called a septal lead. Why? Because it's going in on this interventricular septum in here. Okay, that's kind of the image it's taking. But it's taking an image like this. So we just took the heart. This is an up and down kind of cut like this. Now we're taking it and going. We're getting a new readout on it. So we're taking this and plopping it on the side like this. So now we're seeing those holes like this. So this first one's taking this angle here. That's V1. These are the septal leads. This is lead 2, and then we've got these anterior leads. I believe that's what they're called. And then over here you have the lateral leads. So 1, 2, 3, and 4, 5, and 6, and they're getting readings of this other angle. So now we know we have to take all this information and we have to put it in some kind of chart that people can read. And this is where we get our EKG from. So first of all, when you're going to read an EKG, you have to understand that there are small boxes and there's big boxes. And so it looks, something like this. Okay. So you have this big box like this, and then inside the big box you have these small boxes, and you need to know what this means. The big box, inside the big box, oh great, it just got dark. Hold on one second. So inside the big box you have 5 small boxes, and running along the bottom it's measuring it in seconds. Okay, so each small box is going to be 0.04 seconds, and then 5 of those comprise, because just math or whatever, is going to be 0.2 seconds. Now on the top here it's going to be in voltage, and so one little box is going to represent 1, and then we're going to get 5 of those, and so the big one's going to represent 5. I might need millivolts, so it might be like 0.1 or whatever. I don't remember. And so the standard for this, though, the standard way of measuring this is going to be measured in one big box time-wise, and 2 big boxes up and down. And so it's going to be like this. Okay? So at the side of your EKG machine, either on this side or that side, you're going to see this little thing that's going to go 2 big boxes up, 1 big box across, and then 1 big box down, and then it'll start into reading your EKG. And this just tells you the standard. And they modify this so that it doesn't actually have that. Let's just let you know that that's there. They modify this so that you can look at things more closely or further out. And so if you see that this is like 2 big boxes high, then you would know that they've kind of expanded, expanded the reading for the voltage. And if it was 2 across here, then that means it's reading it more slowly or whatever. In relation to time, so they can adjust this. So that's the first thing you look at on your EKG reading. So now what we're going to look at on our EKG reading is being able to count it. So when we want to count this thing, we essentially have to go from a point until it repeats and gets to that point again. Okay, and of course this isn't to scale or anything, but you're going to count. The easiest way to do this is count from point to point. And the way that you do that is you say, okay, so however many boxes across is going to get me indication of how many beats per minute there's going to be. So if I say, all right, looking at this, I'm not doing this very well, just to familiarize you. It's going to be, if the peaks here are 1 box apart, like this, so it's like just like 1 box, like here's a peak and then here's the next peak, that means this person, their heart is beating 300 beats per minute. Now if it was 2 boxes across between each thing, that means it'd be 150. And if it's 3 boxes across, it means it's going to be, I believe it's 75. And if it's 4 boxes across, I think it's like 60, and then 6 boxes across is going to be 50, and so on and so forth. And so you can see how many beats per minute by just counting the peaks of how many boxes apart they are. That's the first part of this. I'll continue this